Hi everyone, this is Sachin here from BankDB. Today let's implement one simple use case, but which is pretty relevant today. And this is a real world use case scenario. This is about monitoring vehicle using various sensor data. We have a set of cars and each car is sending an event per second, and the event contains 16-18 attributes. For example, the car ID, the coolant temperature, the battery percentage, the battery voltage, current draw, speed, and so on. So we would like to ingest these data, which is streaming continuously, and then we would like to process the data, and based on the processing we would like to take certain action. We will use BankDB 2.0 to implement this use case. There are several relevant files here. For example, the schema definition file, the data file, the test file, and so on. These files are checked in here in BankDB repo under use case and IoT vehicle monitoring. If you check this repo out, then you will get the BankDB and also you will get all these files. And simply you can follow the steps here, which is given here in the readme file for this particular demo. And following these steps, you should be able to replicate this. Now this use case is pretty much real world use case. Let's see the solution overview here. What we want to do is stream all these events into BankDB continuously, create a sliding window within the BankDB streaming system so that we continuously ingest, process, analyze, and store the data or the events. And some of the interesting insights that we would like to extract are following. The first one is we would like to find anomaly for battery voltage for any single event. Now, in order to achieve this, we are going to project the battery voltage based on the previous set of events and the battery voltage contained in those events, and we would like to see the pattern, and based on the pattern we would like to project the battery voltage for the next event, and when the next event arrives we compare the actual battery voltage with the projected battery voltage and take the difference. Then we define a running statistics on this difference battery voltage attribute, and then further we see that if for 5 minutes if the difference in the battery voltage is higher than the average of the difference of battery voltage, then this is an anomaly for me. Now this is not a straightforward run-of-the-mill kind of anomaly detection. It's pretty complex and robust, and when you find an anomaly here you will be pretty confident that there is something interesting happening. The second one is not about projection, but predicting the speed of the vehicle based on the set of attributes and their value for any given event. So each event as it arrives, we would extract the value of certain attributes or set of attributes. We will use the trained model and will predict the speed. And then we will take the difference of the speed which is predicted and the actual speed. And then we follow the same process as we did for battery voltage anomaly detection. And once the anomalies are detected, we would like to stream these events into separate streams. For example, speed anomaly or the battery voltage anomaly streams, so that we can further process those events as we need, or we use that event for notification purpose or alert purposes. Then finally, we would also like to extract the underneath pattern in absolute manner using complex event processing. And the pattern is following: that if we see the speed of the car going beyond 35 unit consecutively for 3 times in last 1000 seconds, then this is an interesting pattern for me, and I would like to continuously see whether this pattern is being replicated, and if yes, then I would like to send these events, these patterns, into separate stream for further processing. And in the end, I would also like to run continuous statistics or running statistics on several attributes like coolant temperature, battery voltage, current draw speed, engine vibration, amplitude, etc. And these running statistics are very handy when it comes to finding some interesting patterns. So this is pretty much that we would like to achieve. This is not straightforward, and typically in any framework, we would require a streaming system, we would require a NoSQL database, we would require to persist the data along with certain indexes or text indexes. We would also like complex event processing, and then we would need AI right there, or at least in some other silo for training purposes, and so on. With BankDB, since it's a converged NoSQL data platform, we will see that all of these things could be done within BankDB using CLI in less than 10 minutes. And let's see if we can achieve that. So the first thing is, once you check out the repo, you will see a folder structure like this. So the first thing we need to do is run the server. Now BankDB server can be run in many different ways, but we are going to run the server in hybrid mode. Hybrid mode means that the server can receive TCP requests, and it can also receive HTTP requests. So the HTTP port will be 18080, and you can give any port number here. And the BankDB is now running in verbose mode. Ideally, you should not run it like this because it's flushing the log data on the terminal itself. But for the demo purpose, we would do it this way. Then we'll go into the agent folder and run the agent. Agent is a very lightweight ePOL based service which keeps monitoring set of resources, in this case log file. And as and when data is written to the log file, it will read the data, parse it if it is supposed to parse the data, and then send it to BankDB server. We are going to achieve all those scenarios using CLI itself. So we'll run the CLI now. Now, first thing we'll see is whether we have any schemas or not. It says that there is no schema registered. So let's register the schema, which is car sensor data schema. And if you run the schema, then you can actually read it using this command. So we see that it's nothing but a JSON file which takes certain attributes that we are interested in, and then it defines certain computed attributes that we would like to compute. And the first thing we would like to compute is projected value of battery voltage based on last 5 such values in previous 5 events for a particular car and for all the cars. Then we would also like to predict the speed using a model called speed prediction model. So we need to train this model also. Then we are taking the difference of the battery voltage and the projected battery voltage, and speed differences for the actual speed versus the projected or predicted speed. Then there is a filter defined here. This filter says that whenever I am receiving an event for which the battery voltage difference is more than 10% for last 5 minutes compared to the average battery voltage difference. So that's an interesting event. Let's train this model. Since we want to forecast or project, so we'll select that. We would use linear regression here. Select the defaults for demo purpose. The file is train.txt. It is a CSV file. The timestamp data is of long type, and it is in the 0 index. Yes, car is the ID, and as you see, we would like to project the battery voltage, so we would select battery voltage here. We would like to analyze the 5 different previous events, so we'd select 5 here, and if you see, it flushes the summary of the data that it has to train model on, and if we say yes, it will start training the model. To see the status of the model, we'll just say show models, and you see that the model is actually trained, and the training status is passed. You can check here also that it actually trained the model, and it tuned the parameters also. Now since the data volume is not high, hence we were able to train the model quite quickly. Now if we just select the stream from the schema, we see that there are 4 different streams here: sensor, battery voltage anomaly, speed anomaly, and high speed increasing pattern. We don't have any events here because we have not yet pushed any event. So let's try and do that. So in the mon folder, there is a helper send line script which actually takes the input file. So let's say that we would use train, and it writes to file which is being monitored by the agent, and then we can define how many records we want to send. So let's send 100 data points per second, and you see it's now pushing. You can come here and see the agent is also sending the data, and we can fire the same query here, and now we see that there are 900 sensor events, and we found few anomalies here also. Now if you go and check the BangDB, you see that there are some errors being thrown from the BangDB. It is saying that although it found the battery voltage projection model because we trained that model, but it didn't find the speed prediction model because we have not yet trained that model. And if you select the data from the sensor stream, you will see that the battery voltage projection is coming because that model is trained, and we didn't need to deploy that model, if you notice, because we have already defined in the schema itself that we'll be using this model. And the moment model got trained within the BangDB, the stream system, it actually picked that model and start predicting here. So it is taking the projection value of the battery voltage and computing the difference, and on this difference it is running the statistics continuously, and then using that statistics it is finding the anomaly. So now we have around 7,000 events in the system. So let's go and train the other model, the speed prediction model. Now here if you see, we are going to use so many different attributes for training this model. So let's actually start training the model. So again, we'll use the same command, train model. This is the model name, schema. And then here we would like to do regression. So let's select the linear regression because it is faster for training. Again, select default for demo purpose. Now here, instead of selecting local file, we'll select stream because data is in stream, and name of the stream is sensor. You can just guess here the amount of data that you are going to put here from the stream directly. We don't need to be correct here, just an approximate value. And select the data for last 3600 seconds. So let's select the default here. The 0 is the index for the target value, and we can select the speed at which we would like to train the model. Let's select the medium speed, and it could be hybrid. The data or the set of events or attributes, we have all numerical, so select 1. And we don't wish to scale the data, but we would like to tune the parameter. And the first is speed, since that's what we would like to predict. Then we need to add all the attributes on which we would like to train the model. So, and the last one is and then we'll say yes, and we'll train the model. Again, show models to see the status. The model is trained, and you can check here again. And since the model is there, now if we push another set of events, we'll see that the speed is also being predicted. So we have another file. We'll use the test file from where we'll push the data, and 10 events or 5 events per second, so that we can visualize properly. Now if we see select stream from cars, we'll see that certain speed anomaly is also coming here. Now there is another cool thing about BangDB that if you remember, we ran BangDB in a hybrid mode where we were pushing TCP data so far. Now let's actually use REST API to see some of the charts and graphs on Grafana. So here I have created certain set of graphs, 10 charts here. So we'll try and see if we can get the data. So if you see, the data is actually showing up here for last 15 minutes, and this is for speed anomaly, if there are any, and we see that there are few such events, and this is the running statistics for coolant temperature. So if you see the last 5-minute data, then you will see that the data is now clearly visible here. So on. Now if you see, there is no pattern that we have seen here, because data is such that the speed is not crossing 35 unit consecutively for 3 times or more. So we'll try to replicate this using some artificial data. So there is an event that I have provided here. We can just use this one. There's another cool thing about BangDB that instead of actually drawing all the graphs on Grafana or any other dashboard, if you like, you can see the graphs within the terminal itself. So let's say that we would like to plot the speed and the predicted speed. Then we can simply use this command. And if we run, you see that there is a speed and the predicted speed which is being drawn, and you can keep drawing for more and more data if you just click yes and yes, yes, and so on. So that's it. We actually were able to ingest a lot of data into the system, and you can keep scaling for higher number of events per second. BangDB ingests with more than 5,000, 7,000 events per second, doing all these kinds of processing for every single event as it arrives. And then we trained few models to project the battery voltage and predict the speed. And then we found anomalies, and we also implemented a complex event processing. And finally, there was a dashboard that we created, and we visualized some of the data there. So this is pretty much for this use case. I hope you like it. If you want to take it forward and implement it in your own scenario, in your own context, please feel free to do so. BangDB is completely free. You can download and implement this. You can actually use the files here to get started, and then you can add more things into your schema in order to enable a lot more features that I have covered today. Thank you very much. Thanks for watching. Have a good day.